Hello, everyone. This session we introduce golden triangle. Golden triangle is it belongs to the triangle geometry, and I always think about the triangle geometry is one of the most interesting part of the geometry. And so there's a lot of interesting things here if you really love the geometry. So the golden triangle is one of the interesting factor of the triangle. Is a special triangle. So let me introduce what's golden triangle to you. Anyway, why it's called golden triangle? You can check something. They can make a very beautiful graph. Uh, you can check that. You can easily find out. But right now, I'm focused on introduce its characteristic and how we draw those kind of the characteristic. Okay, so first, the golden triangle was, we say the golden triangle, we just based on this triangle ABC. Okay, ABC. Okay, the golden triangle first is isosceles triangle. Isosceles triangle, which means the two sides of a triangle are equal length. Okay, so we just look at here ABC, AB, and AC are equal. So it is this is the first requirement of the golden triangle. So U equals to V. So if it is the characteristic of isosceles triangle, if the two sides are equal, then their corresponding angle or the equal. So the corresponding angle C and angle B are equal. This is isosceles triangle. Okay. If it is only this, it's only isosceles triangle. They have more special. More special here is if we make angle A as delta, angle A is theta, then angle B and angle C will be 2 theta. That's the difference, right? So angle B and angle C will be 2 theta. So if you ask me what's the angle for theta, so I think it's also easy, right? So angle A is equals to 180 divided by 5. Why? Degree, huh? Why? Because angle ABC together is the internal angle of the triangle ABC, right? So their summation of the internal angle is 180 degree, and they have totally 5 theta degree, right? So divide by 5. So the angle A is 36 degree, angle B and angle C is equals to 72 theta. Okay. So this is the exactly characteristic of a golden triangle. We don't even need to mention it's a isosceles triangle. We just need to say their 3 triangle are 36 degree, 72 degree, 72 degree. Then it's a golden triangle. They can be small, they can be bigger, they can be any similar triangle, but with these angles. Okay, so what's the characteristic? Why we just choose this one? Is that because of funny 2 divided by 1? No, not only by this one. They have special characters. Special characters is their size, the division of their size. The size divided by its base, like U. Remember, U is one side, right? Divided by what? The base. Base is W, right? The size divided by base equals to what? Equals to 1 plus square root of 5 divided by 2. Always like this way. So you will ask me why it is like this way. Why it's like a specific like this way. And I have to write in because they are same. So it's come as V over W, right? Why it's come like this way? Okay, so in fact, this is not hard to get, and I just show a short demo for this. Okay, so from the point A, I will draw a line passed by the base size. Okay, I will draw a line. Okay, I will draw a line here, and this line is perpendicular to the size of BC, the base. I call this one is E. Okay, I call this is E. Okay. Anyway, this this is you don't necessarily need to base on this what I'm drawing. Okay, I'm not drawing very perfect, so you might have confusion later. So then we form the two right triangle, right? It's right triangle, right? The two right triangle is what? A A A E B, right? A E B and AEC. Am I right? We form two right triangle. These two right triangle are similar triangle. That's one term I want to introduce as well. I'm not sure if you still remember what's called similar triangle. Simply speaking, if the two triangle, their both internal angles are corresponding angles are equal, then they are similar triangle. Just give example. If the triangle is if one triangle the three angles inside internal is 30, 60, 90. Another one triangle they are 60, 90, 30. So their internal angles. So they are, I mean, this different three angles. So they are similar triangle. So for the right triangle, we only need to find another angle except the right triangle is equal. Then we can identify it's a similar triangle, because the simple explanation is, if you already know the two angles in a triangle, you definitely know the third triangle, right? Because their summation is 180, so definitely you can identify the third triangle, right? So the same thing here. Since this is a right triangle, so they have one angle are the same for these two triangle ACE. Triangle ACE, and then triangle what? Triangle AEB, right? Right? They have two triangles. Their two angles are same. First is the perpendicular angle, right? Perpendicular angle, both. The second is their base angle, right? We know that. So definitely this angle, the two angle that is separated by this line, all the same. So which means this line perpendicular to the base is bisector the angle into two equal angle. Okay, so yes, so this will be, if this is data, so this will be only 1/2 data, right? 1/2 data. So let's see if the similarity is if the sine 1/2 data equals to what? Equals to what? WB, right? Divided by U, am I right? WB divided by U, right? This is the opposite side. This is the hypotenuse, right? Right? So WB, since they are they are similar triangle, and they are not only the similar triangle, they are congruent triangle. They are congruent triangle. The congruent triangle is their corresponding sides are equal length and the corresponding angle are equal. Why I say they're congruent? You see that for ACE, first their angle are the same, right? Angle all equal, and you see they share the common side, so this side is equal, and another side is also equal, right? Right. So they are congruent. This one of the proof how to prove two angles are congruent, right? If their two sides are equal length, the angle in between these two sides also the same, so they are congruent triangle. So these are congruent triangles, so which means that WB is 1/2 of the W of the base, right? 1/2 of the W, right? Okay. So we can write in is equal to 1/2 of the W divided by what? Divided by another side is U, right? And the sign 1/2 theta is since sine 18 is 1/2 of theta equals to -1 plus square root of 5 over 2. They have very formula. You can find this what is the angle of the sine 18. So sine 18 equals to this, and also then you can equals to 1/2 of the U over W. So definitely you reverse both sides. So 2U over what? 2U over W is equals to what? 2, right? -5 plus nothing. Am I right? All right, right? Yeah. So so this can be cancelled, right? So U over W here is equals to -1 1 plus square root of 5 over 2. Is this the same? 1 over, I think it's the same. We just need simplify on this one, okay? Simplify this one. Let me move to this angle a little bit, okay? Simplify this one, so we can get v times -1 plus square root of 5 times what? -1 minus square root of 5. Can we, right? So this is -1 minus square root of 5. So what's this below? A plus b, a minus b. So a square minus b square. So -1 square minus square root of 5 square, right? How about up? Up the same, no change, right? So, but up we can draw negative, so we can 1 plus square root of 5, right? So let's see the denominator. So it's 1 -1 square is 1. Square root of 5 is 5. So 1 minus 5 is -1. Am I right? -4, sorry. 1 minus, yes, 1 minus -4. 5, 1 minus, yes, -4. Uh, sorry, that's a little mistake. The sine 18 is not over 2, but over 4. So, so here the 2 can still keep. So this should be -2. Sorry. Okay. So now we can see that's totally equal, right? So it's if we divide it by negative sign, so it's 1 plus square root 5 divided by 2. So what we prove is for the golden triangle, exactly the size, the two sides, the equal side divided by their base, they have they have the fixed ratio is 1 plus square root of 5 over 2. Anyway, this is not ending. There's more interesting things here. So let's look at here. I just changed the direction of the triangle. If you compare with the triangle I showed that, the golden triangle. From one of the base angle, I draw a bisect line. That is an angle bisect line. So which means this line separates the angle C into two equal. Of course, if two equal, they are data, right? And if this line intersection with the AB another side and the intersection point is D, then we get the same thing here is AD divided by what? Divided by DB. And what's that mean? It's this part divided by this part. Yeah, equals to what? 1 plus square root of 5 over 2. It's very familiar, right? Very familiar, 1 plus square root of 5, right? So same as the size divided by base, right? So why it's like this way? So in fact, it's easy to prove. Okay. So here we have to let's observe the triangle CDA. Triangle CDA. Triangle CDA. Since there are two angles are same, so they are isosceles triangle, right? So their corresponding sides are same length, right? So here they're same length. So what's this length is AD equals to what? Equals to CD, right? AD equals to CD, right? So now we can change here is equals to CD divided by DB. So what we want to find is equals to 1 plus square root of 5 over 2. So look at here, CD over DB, CD over DB. In fact, in another triangle, which triangle is triangle CDB? I now tell you this triangle is another golden triangle. Am I right? Because this data, this of course is two data, right? If this data, these two data, how about this one? Of course it's two data, right? Of course it's two data, right? Same data, two data, two data. So of course it's two data, right? Of course it is two data. So this another what? Another golden triangle. Since this is another golden triangle, the size divided by base, it's 1 plus square root 5 over 2, right? So yeah, so today we spend a lot of time to explain golden triangle. In fact, we mix with the knowledge about the similar triangle, isosceles triangle, and we do a lot of proof. I hope you like this session. Okay, thank you. Have a nice day. Bye-bye.